Hello, ladies, gentlemen, and in between, and welcome back to another episode on Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to be starting a new chapter. How exciting! It will be coordinate geometry, so the geometry of x and y graphs, graphs that intersect, all that crazy stuff. And this first episode will just be a little recap of the xy plane and the xy coordinate system. And you might think you don't need to watch this video after hearing that, but I think you should anyway, because it's got some. It might clear up some stuff you have about the xy plane, like how graphs work and how it really works. Like, because you might have seen equations of graphs that have like y squared plus y equals x squared, stuff like that, not just y equals yourself with x, and that will help clear up any confusion you have about that. But without further ado, let's get into a new chapter. Whoop! Okay, so I'm sure the xy plane needs no introduction to all of you people doing year 12 and maybe even beyond maths. Maybe you're even watching this recreationally, in which my love goes out to you. Anyway, so how the xy plane works is you've got one number line, which we call the x values, which go from negative infinity to positive infinity and includes every whole number, fraction, real number in between. And you've got another one going perpendicular to it, which goes from negative infinity to positive infinity, and they're called the y values. Now, the whole reason we'd invent something crazy like this is because it allows us to create this two-dimensional plane where we can label points, where each point has an x coordinate and a y coordinate, and we write its coordinates as its x, comma, and then its y. For example, this one looks about 1.9, and then it's close to pi, about 3.1. So that has coordinates 1.9, 3.1. And in general, they have coordinates x, comma, y. And the reason we'd want to create something like this as well is because this allows us to represent a relationship between two variables, x and y. For example, you might be measuring the relationship between temperature and energy that you put into the system, and then you can plot all the points on the graph on the xy plane and get a nice little graph, and you can see how these two variables relate to each other, how they change with each other, and so forth. Now, how do you even do something like that? Well, you've got to first have your relation between variables. So let's see what I mean by that. For example, you might have something like you have one variable y that when you square it, it equals 2 to the power of x. Now that is a monstrous little equation. I'm going to rub this out if you guys don't mind. Now how we're going to represent this on the xy plane is quite very simple. We look for all the points that have coordinates x, y that satisfy this equation. Now what I mean by that is, for example, consider the point x equals 4 and y equals 4 actually, yes, which would be somewhere around here, 4. Now, that satisfies this equation. You can check 2 to the 4 equals 16 and 4 squared equals 16. So this is a point on the xy plane where the y coordinate squared equals 2 to the power of the x coordinate. So we can colour that in on the plane. And let's suppose we go looking for more of these, where the y coordinate squared equals 2 to the x. And if we colour all the points in that have that property, eventually we'll be able to draw a smooth curve. And this is very important because we can see the relationship between these variables. For example, when x is a positive number, y goes up rapidly. For example, that means if your temperature is positive and going up, then the amount of energy you put into the system has gone way up, and such like that. Now, I'm sure you're used to seeing stuff not like this, not as like y blah 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 equals 2 but x blah 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 blah. You're usually seeing it as y equals some whole thing with x, with y on its own. And the reason that is because that is a very nice interpretation and very useful to us. And I'll show you what I mean if I just rub this one out. For example, let's say we have ye old classic y equals x squared. Y equals x squared, brilliant. Now the reason this has a wonderful interpretation is because you don't really have to go looking for all the points x, y that satisfy that equation. You can just choose an x value, say 2, square it, and you get that the y value should be 4, which will be way up here. And boom, you've found a point x, y that satisfies that equation, and you can draw that curve very nicely. Now that is very significant. It allows us to create wonderful pictures of graphs, by the way, lovely to look at, and also being able to really see the relationship between the variables. As you should know, if you've already seen my other videos, that this graph ends up looking something like this. Very nice. And there, you can really just get a visceral look at what this function here is actually doing. For positive x values, y shoots up very quickly, as you'd expect to, because you're squaring the input. And for negative values, it also shoots up, which you'd also expect, because negative number squared is a positive number. So as you can see, the xy plane and the xy coordinate system is very, very useful for showing a relationship between two variables, and more importantly to us, plotting functions. Because you might notice that x squared is just a nice little function, f of x equals x squared, and if you can plot it on the xy plane, you can get a nice visual for what it's doing. And if you remember from chapter 2, it's very convenient to spot quirks and features of the function, for example, a polynomial's roots. So there you go. You've met the xy plane. I'm very excited to show you more of it in the future. Next video, and then the whole following chapter, we'll come to develop a lovely little relationship with the xy plane. We'll come to learn some special shapes that it can create, some nice equations of those shapes, how to manipulate them, and how to find out interesting properties of the graphs. For example, when two different curves might intersect. And that was a quick video, and that'll be it from me. Just a nice little introduction and recap as to the xy plane. Guys, I hope you enjoyed that beautiful video. I'll see you in the next one, yeah? Peace out.